Good day everyone, welcome to another episode of my YouTube lesson. In today's video, we are going to proving the formulas of Graham's law of diffusion. So from the definition, the Graham's law of diffusion states that the rate is inversely proportional to the square root of the vapor density, and let's introduce this constant. The constant will be equal to K upon the square root of the vapor density. So after we have introduced this constant, let's make the constant as with the formula by cross multiplying. K will be equal to rate multiplied by the square root of the vapor density. We can assume that we have K in two places. So K1 will be equal to R1 multiplied by the density 1. So also can see also have K2 to be equal to R2 to the root of multiplied by the square root of density. So this sign, which is known as density in physics or in chemistry, normally call it rho. So let's combine. Let's say K1 to be equal to K2. So we are going to have our K1 is equal to R1 into the square root of density 1, R2, and square root of density 2. So we can divide R1 by R2 so that we can have the same thing that we have up here. So we just have it like this, density 2 upon density 1. So this is one of the first equation that you need to take note if we are dealing with the Graham's law. So also we also have the Graham's law. We also have the rate also to be equal to volume all over time. Rate is volume all over time. So you can change this R1 and R2 into volume and time. Our R1 to be equal to V1 upon T1, and also R2 also be equal to V2 upon T2. And from the first formula that we have here, the first proving that we have here, we can say that R1 divided by R2 to equal to square root of density 2 upon the square root of density 1. So our R1 is V1 upon T1 divided by V2 upon T2, which is equal to density 2 upon density 1. So we are going to do a mathematics here whereby we change this place, this division will change to multiplication, and T2 will go up. So we are going to have V1 upon T1 multiplied by T2 upon V2 to be equal to square root of density 2 upon square root of density 1. So in the final answer here, we can have V1 T2 upon V2 T1 will be equal to the square root of the density 2 upon the square root of density 1. So you can also make use of this another formula. So if you are dealing with the Graham's law of diffusion, the same way you prove for the rate is inversely proportional to square root of vapor density, you are going to use the same thing with the inverse proportional to the square root of the relative molecular mass. But just such that sometimes if you are using the relative molecular mass, you will not be given the molar mass, sometimes the relative molecular mass, but you will be given the vapor density. So the relative molecular mass is equal to vapor density multiplied by 2. So you multiply the value by 2 so that you can get the M. So the same way you prove for this same steps that you prove for this one up to this point. So the same thing we are going to do here also.